Hello and welcome to a webinar on how reliable and cold chain infrastructure can ensure efficient blood management in India. My name is Prabhat and I will be moderating the session. Thank you for joining us. This webinar is brought to you by B Medical Systems in association with ETHealthworld. Recently, the Drug Controller General of India issued guidelines on preserving blood and blood products by storing them at cold or freezing temperatures. According to the new guidelines from October 2022, all the blood bank cold chain devices need to be medical grade and Class B certified. Before we begin, I would request our viewers to share the questions in the chat. We will address them as and when the time permits. Today we have with us Dr. Reema Menon, Medical Officer, IMA Blood Center, Kochi, Dr. Nidhi Bhatnagar, Head and Professor, BJ Medical College, Ahmedabad, Dr. Rajesh Sawant, Consultant, Transfusion Medicine, and Histocompatibility and Immunogenetics, Kokilaben Dhirubhai Ambani Hospital and Medical Research Institute, Mumbai. Dr. Abhik Banerjee, who's the Zonal Technical Chief, East Zone, Apollo Diagnostics, Unit of Apollo Health and Lifestyle Limited, Calcutta. Then we have with us Dr. Varun Kapoor, Consultant and in charge Transfusion Medicine, Paras Hospitals, Gurgaon. And lastly, we have with us Dr. Sumati Hiregaudar, Associate Professor, Department of Transfusion Medicine and Blood Center, Tata Memorial Center, Advanced Center for Treatment, Research and Education in Cancer. I welcome everyone here and thanks everyone for joining in. To begin with, and to set the tone for this conversation, my first question would be for Dr. Menon. Dr. Menon, can you hear me?
Yes.
Dr. Menon, my first question for you would be, why is there a pressing need for an efficient cold chain system for blood storage and the importance of correct storage of blood?
Thank you, Prabhat. Good afternoon to my fellow panelists and the viewers. It's very important for us to understand the cold chain processes that happen in any blood center across the world. Now, blood transfusion is an essential part of modern medical healthcare. And if used correctly, it improves health and saves life. I mean, this is a very cliched statement, but that's what happens. But it's a therapeutic intervention. So it could result in acute or delayed complications that carry the risk of morbidity and mortality. Transfusion transmissible infections are one of the most popular complications that people know about blood transfusion. But for safe and effective transfusion, we need to look at we need to have implementation of certain strategies for blood safety. Now, this has been defined very clearly by the WHO, and it has been shared with all the member nations, including India. We are also a signatory to that program. Now, this means we need to establish well-organized, nationally coordinated blood transfusion services with quality systems in all areas. Quality is the key mantra in all of these activities. The blood collection has to happen from voluntary, non-remunerated, and I would add repeat blood donors, which ensures safety. We need to have a testing program as directed by the regulatory authorities for all units of blood that are collected. Every time it has to be tested for the transfusion transmissible infections. We have to do a blood grouping every time a donor comes to us, and compatibility testing has to be complete before certain products are released for transfusion. Reduction of unnecessary transfusions is very important through effective patient blood management programs and protocols that are available nationally and internationally. And this also includes simple alternatives that can be used in place of transfusion if necessary. So this is a part where the clinicians are also involved in the action.
Dr. Menon, could you also share some insights on the need for correct procedures for storage, packing, and transportation of blood, yes, and also on the major challenges and solutions?
Yes. Now, when we talk of the blood cold chain, it is the chain between a vein to vein journey, I should say. The vein begins with the blood donor who donates his blood and ends with the administration to a recipient. So this has a series of interconnected activities which involve personnel, people who are involved in every process that is there, materials that are used, machines that are used, and methods that are critical to collection, testing, separation, storage, and safe transportation of all of the blood components. This has to be a cost-effective process because it can be achieved only if we have technically appropriate equipment which have been approved and licensed by the regulatory authorities. We need to make sure that it's available for storage and transport at all levels of the healthcare system. That's not just with the blood bank or just with the donation process, but right to the end, the last mile, I should say, of the chain. Now, blood components are separated after once we obtain the blood donation. It is separate. It is brought in a regulated environment to the blood bank, where the blood bank takes over separation of the components into its constituents. That is the basic activity of the blood bank. Now, these blood, and then we also have another class of blood products which are manufactured by pharmaceutical processes using plasma that is donated by human beings. So the blood components, means the whole blood and red blood cells, are collected at a temperature of body temperature of 37 degrees. And to maintain its vital properties, we have to make sure that it is cooled to, say, around 10 degrees, transported in storage in refrigerated systems, and stored at 4 degrees until it is used. Now, these products, that's whole blood and red cells, are stored in specialized blood bank refrigerators at 2 to 6 degrees for a period of 35 to 42 days. Domestic refrigerators are not to be used for storage of whole blood or red blood cells. Now, this is very important because the blood storage refrigerators are specially designed, medically approved refrigerators, which have very special features, and we have to comply with that. Platelets for transfusion are stored at a temperature, room temperature, ambient room temperature. In the laboratory, when we say ambient room temperature, it is between 20 and 24 degrees. These have to be stored in specialized equipment called platelet agitators, incubators, which maintain a temperature of 20 to 24 degrees. And they agitate continuously to keep the product viable and effective. These have a shelf life of 5 days. Plasma that is separated from that is a liquid part of blood, which is separated from the whole unit has to happen within 6 to 8 hours of collection of the donation. And this is rapidly frozen at minus 80 degrees. It could be in a refrigerator, in a deep freezer that is maintained at minus 80, or it could be using contact shock freezers that are available, which are very, I should say, very effective. There is a lot of saving as far as electricity is concerned, and they need not work 24/7. And they're really good workhorses, which help to freeze a lot of plasma. The core temperature is reached in these contact shock freezers, say within 2 hours of freezing. And once it is frozen, because the plastic bag systems that we use are very brittle at minus 80, we need to transfer them to minus 30 or lower freezers, and they have a shelf life of 1 year. Now, plasma contains all it mainly contains water. It contains all the electrolytes. It contains the clotting factors, your hormones, and name it, the proteins, all of that, which are actually stable even at 2 to 4 degrees. But essential clotting factors which help in reducing or stopping bleeding, this can diminish in quantity and quality if it is not stored below minus 30 degrees.
Thank you so much. Thank you so much, Dr. Menon. Moving ahead, since we have limited time here, so let's take this ahead. I'm so sorry. Dr. Bhatnagar, if you could just share your views on the role of training and skill development of various players in the cold chain when it comes to management in India?
Thank you, Prabhat. And as Rema ma'am already said, that it's a vein to vein, process. So from the donor vein, when the blood is collected and when we store it at proper appropriate temperatures in the blood center, and again transfer it or issue it to a recipient. At each step, the quality is maintained, and along with the quality, what needs to be, what is critical is maintenance of the temperature at each step. Along with the blood components, also the reagents in the blood center, whatever reagents we're using to maintain those, so as to achieve the blood safety in terms of providing quality and safe blood to the patients who require. As you're asking me about the personnel working in the blood centers, they are basically from medical or paramedical background. So this aspect of the blood banking or the cold chain maintenance is basically engineering. So a lot of what you said is really important. It's critical to train the personnel who are working and who are handling these blood products, maybe from the outdoor blood donation camps when the blood is coming, so or the reagents when they are shipped. So at each step, the training of the personnel who are handling these things is very important, and it needs special attention. And NACO has done a wonderful job. Last 15 years I've been involved in this training. My center was a training institute for the whole of the state, Gujarat state. But this point, which the cold chain maintenance and the equipments which are required for the cold chain maintenance, and the monitoring of the temperature, handling of these equipments, maintenance of these equipments is definitely there is lack of training in this, and definitely needs special attention.
Dr. Bhatnagar, could you also share some insights on how sustainable management of blood?
Yeah. Definitely, sustainability in these
the community can be achieved.
Yeah, definitely. If we are avoiding the wastage which is happening due to the poor storage, then definitely we'll be able to achieve this, the needs of the community, the blood needs of the community, if we avoid the wastage. Because blood, as you know, is a precious commodity, and it cannot be obtained in the or produced in the factories. So it has to be got, from the human resources. We have human resources. So definitely, it's a crime if we waste it due to the poor storage.
Thank you so much for that, Dr. Bhatnagar. Dr. Menon, coming back to you, since Dr. Bhatnagar has shared some insights on the criticality and the importance of preserving blood and its components, could you share with us the major reasons for blood wastage and how can this issue be addressed?
Blood wastage is most often when a product that has been prepared and ready for transfusion does not reach a patient, but it goes down the dustbin. So like the blood cold chain for transport and storage, we need to make sure that at every level of storage, the temperature of the product is maintained. We need to have a very effective inventory management. That means we need to know whether our supply and demand match, and we have that little buffer stock which is necessary whenever there is a calamity or there is a disaster or anything. So that decision is a very important one based on the utilization of blood by your institution, or mine is a standalone blood bank. So we look at what our clients require, and we make sure that that stock is available with us at all times. So we need to match that. Now, this would mean that we have to motivate our donors and educate our organizers of blood donation camps not to hold those mega melas for donation, which runs into hundreds of units being collected on one single day. That makes transport difficult, that makes processing and separation testing difficult, and it brings down the quality of blood. So actually, as the National NACO has given us guidelines up to how to conduct a blood donation camp, what is the minimum number that you could collect, and what is the staff or personnel required for that. So if you could follow those guidelines, which make a lot of sense, And they also have described the environment in which the collection happens, so that you can avoid a lot of the unnecessary donor reactions, and finish your collection in a specified time and reach to the blood bank. So the earlier it reaches the blood bank, the better it would be for processing. And of
ma'am,
course,
I'm so sorry. If you could also comment on how technology can help improve
yes,
blood bank safety.
yes, technology improves because we need to have very robust systems which will record your temperatures, for example. The temperature recording systems need to be updated. Now that we have so much of strength in our IT work and software development, this could be a very major role. They could play a very major role in making sure that blood is safe during its transport and during this. We need to have equipment, devices like data loggers, which communicate with the software that is available in the blood bank or in the recipient end, and let you know in real time at what temperature is it being transported, so that even without opening the container, you know what is in what you're in for and what is literally inside that container. So that is how this, and then we also need to have the medical grade transport systems, rather than using boxes which are what should I say, which are just available for us, and we thought if we could make do with it, but we are dealing with something as precious as blood, and all biological fluids are very thermosensitive, so we want to make sure that that is retained. So we need to impress upon our clients that they need to use proper transport systems, which can be monitored, which can be repaired, which can be, you can take care of it to the end.
Thank you so much, Dr. Menon. Dr. Bhatnagar, just before I come back to you, Dr. Kapoor has something that he would like to share with us on the training and wastage of blood.
Yeah,
Dr.
I
Kapoor,
just want, everything was beautifully summarized by Rima ma'am. I just want to add one additional point, that we just not, rather than just focusing on the wastage of blood and in blood banks and in the camps, etc., we also need to focus on wastage of blood at the patient side. We need training of our nurses of the proper handling of blood and blood products, and also training of our junior residents and doctors, surgeons and physicians also, because many a time they are not aware of the proper storage of these blood products, and there has been incidences where the blood was found lying to near the patient's bedside. The proper conditions were not followed, and it resulted in the wastage of blood. So we also need to address on all those points as well. Okay, thank you.
Dr. Bhatnagar, you wanted to share something yourself.
Yes.
Go ahead. And
same thing what Dr. Kapoor said. Recently, we had a round in our hospital. It's a tertiary care teaching hospital, and we found the blood kept in the domestic fridge in the OT. So definitely, the practices, wrong practices, need to be addressed. And as he said, patient blood management, unnecessary use of blood is all very rampant. So ताकत बढ़ाने के लिए blood चढ़ा दो, all that stuff is still going on, and so we need to...
Thank you so much, ma'am. Dr. Menon, yes, please go ahead.
Yeah. Is it me?
Yes, Dr. Menon.
I feel that the end users, that is the clinicians, need a lot of training, and the training has to be a continuous process, because somewhere down the line they forget what they have to do. So I think we need to have training not just for the paramedical staff and the juniors, but the seniors who ask for blood also need to be trained and updated. So we need them to follow the systems that are available. The tools are all available. You have the maximum blood donation, surgical orders schedules are there. You have what alternatives are available, and whether you can avoid using blood if you're having a planned surgery. So all of this is available. And I think we as blood bankers need to enforce that we should also be consulted when you're planning your chemotherapy for your patient.
I just have a question for Dr. Bhatnagar here. Ma'am, could you please explain to us about the blood transportation box, like the ones that are used and the ones that are recommended So if you could
Yeah,
just
so
elaborate
the
on
blood
that.
transport boxes, they are a vital part of any blood center when we want to get the blood from the outdoor blood donation camps and all. So it ideally it needs to be lightweight because our attendants are going to handle it, carry them and put them in the buses or our transport vans and all. They have to be at the same time sturdy, robust, easy, and a digital display. Ideally, there should be a digital display which is showing us the temperature inside, and it has to be again secure and lockable. And then, of course, the number of hours, the longest number of hours the cold chain is maintained inside. Minimum, I feel, 12 hours should be there. So that is the ideal transport box which we are looking at.
Thank you so much for that, Dr. Bhatnagar. Moving on to Dr. Sawant. Dr. Sawant, could you share with us the criticality of proper temperatures during storage and transportation?
Yes, definitely. And before that, a big hello to all my fellow colleagues. And I also want to thank the organizers because you thought of this topic, because I don't think we have, very commonly such kind of topics being discussed. So this is a very, very pertinent and a very rarely discussed topic. So thank you really for bringing this up. Well, as far as temperature is concerned, as already the previous two panelists have highlighted, that maintaining the temperature during storage, and not only during storage, but transport or even during the routine processing is very, very important. Like if we just follow the critical control points in the blood collection process, the commonest problem is once the blood is collected, then when it is waiting for blood components to be separated, it has to be maintained at a particular temperature, which has to be air conditioned room temperature around 22 to 24 degrees Celsius. Now this ambient temperature, the humidity, all this may not be monitored at many centers. Plus, you know that in India, the ambient temperature, especially in summers in various parts of our country, can be really challenging. So, the room temperature has to be maintained properly. Another possible gap and very commonly observed gap is when the components are separated and then you are waiting for the labeling of those components, so to take them on into your inventory. Again, there is a lot of time that the units lie just outside. Many a times the technical staff, they miss keeping them back onto the platelet agitator or into, the refrigerator. So there are obvious gaps where temperature is not really regulated or it is not stored in the correct temperature. And these, if they are more than 30 minutes time span, then they are going to definitely affect the quality of the product that we are looking at. So I think there's a lot of insight, a lot of training that is required. Also about the previous point, at the patient's bedside, when the previous two speakers have spoken about, one very common experience is that the clinicians or the junior doctors, they fail to look at the TPR, BP or the basic evaluation of the recipient before ordering blood. What happens is that blood is ordered and then it has to be sent back, because then later on they realize that the temperature, the patient is febrile, the temperature is a little high, or the patient had to be shifted somewhere for some radiological investigation, etc. So these are little practical things where if we have a little better understanding of the process, a little better coordination, then wastage of precious resources can definitely be limited.
So could you also comment on stem cell therapies, as in the challenges with it, in storing stem cells and transfusing it and doing the surgeries?
Yes, again, very important, because these days, I think every other hospital is practicing autologous stem cell transplants. Autologous transplants are not all that difficult now. We have the expertise, the know-how, and the setup also for autologous transplants. What does this mean is that the autologous hematopoietic stem cells also need to be cryopreserved and stored at sub-zero temperatures. Again, most of our centers, we resort to the mechanical deep freezer and not the liquid nitrogen based storage system. most of us, at least I think 90% of the centers use the mechanical deep freezers, and this may be uncontrolled rate freezing. So here comes the basic importance of your, when you procure such equipment, storage equipments, how well have you looked at the performance qualification? How well have you validated your system? Is there a temperature mapping being done? So I would in fact start with these aspects, because these are generally a little, neglected aspects. Now, thanks to accreditation and also the know-how that I think everyone knows that, okay, when you have a new equipment, you need to have a IQ, OQ, PQ document. But that's it. What we do is we generally accept whatever the manufacturer has given. Many a times we don't even look at what parameters have been tabulated and what results have been observed, etc. Very few centers do actual validation before putting the equipment into use. So these are certain points for improvement. When we are talking about stem cells, it's very, very important because it's going to be the lifesaver or the lifeline for the recipient. And the viability of these stem cells, not only after collection, but after thawing. So after cryopreservation and storage for, say, whatever, few weeks to few months or even years also, depending upon the clinical scenario, if you look at the viability of these stem cells, they may be definitely affected if it's not a very well-maintained storage unit. So we have to look at all these aspects: proper temperature monitoring, the defrosting of these units, and having a backup unit available, etc. These are simple things, but many a times we just leave them out, and only when there is an outlier or there is a failure, then we look at all these problems. So in fact, out of our own experience, when we did as a pilot project the viability assessments of stem cells which were stored for various periods, and then when pre-infusion we looked at their viability, the viability may be affected or rather lost anywhere between 10 to 15% to the minimum to up to 50% also. Of course, there are a lot of other factors like the concentration of the cells that were stored and the DMSO concentration, etc. But temperature and the dependency of the temperature or the way the temperature was maintained is very, very important. And therefore, I feel validation of these equipments is very important.
Thank you so much for that, Dr. Sawant. Dr. Hiregowda, would you want to add something to this?
Yeah, thank you, Sawant sir, for adding, about the cells and the importance of cellular therapy in treating a variety of diseases and conditions. So, and their viability and the potency is definitely what we look forward for a curated treatment. So, and temperature plays a vital role in this. Though we have some cold chain solutions like what Dr. Sawant mentioned about cryopreservation. There we biopreserve the cells so that they can be used for a later time whenever they are required. We also have certain equipments, not to forget our old deep freezers, and also the refrigerators which can preserve the cells at 2 to 8 degrees centigrade and keep them viable for a short while. And also we have temperature control devices, whereas the cells can be transported, for distances and wherever the cells are required at a patient bedside. And temperature loggers, which are being used to maintain the cold chain tracking. These containers are very crucial in managing the viability of the cells. So, and what Dr. Sawant also mentioned was about the quality management systems. In cell therapy, we always believe the product, the process is the product. If you aim at a good quality product, you have to make sure your processes are set right. With those things, I say that quality and efficacy of cell therapy or products is based on the comprehensive cold chain solutions what you have, and thereby you ensure that patient receives a safer product. Thank you.
I also want Dr. Hiregowda, if you could comment on how can emerging and advanced technologies assist in stem cell preservation and transportation?
Yeah, we have biopreservatives nowadays, which can keep the viability of the cells for a longer duration of time. With the advancement of these biosimilar molecules like the DMSO with other constituents of pentastarch, these are one of them. And also, maintaining the cold chain devices with Internet over Things, which can track the product temperatures all throughout the world, and wireless data loggers. These are some of the things, and we have these refrigerants which can outreach to the distance of places based on these solar powered refrigerators, which can reach to the patient care at distant places.
Thank you so much, Dr. Hiregowda. Dr. Sawant, if you could add a few more things to this, another dimension to this.
Yes, basically, as Dr. Sumati also said, see, when it comes to stem cell therapy, it's very important, rather it's our responsibility to maintain the quality of the product properly during storage. And that's going to be a complete game changer, because if by any chance the viability is lost partially or completely, then there is no second chance for that patient, for salvage. And also it involves a lot of ethical issues also, because we take consent from the patient, from the family, that we are going to store your harvested cells and they will be viable or available, say, for whatever few months or few years and things like that. So before making such a commitment, what I come back again to is the validation of our systems, and knowing for sure that whatever we are storing at -80°C in a fully loaded deep freezer, how long are we going to have that basic minimum, say, assurance that 75% of the cells at least will be viable at the end of 6 months or 1 year or 2 years. So I think that is the exercise that each one of us needs to do to validate our own systems.
Thank you so much, Dr. Sawant. Moving on to, since we've spoken to people from the blood bank, people treating patients, moving on to diagnostics. Dr. Banerjee, if you could just comment on the importance of advanced cold chain infrastructure in a medical laboratory.
Thank you for the question, Mr. Prabhat, and thanks to the organizers for this pertinent topic which needs to be discussed, and it's the need of the hour. Maybe we discuss many things about the blood banks, the analytical aspect or the diagnostics, but maybe we miss the pre-analytical factors. Thanks for the organizers for giving me the opportunity also. After getting to know so much about the importance of the cold chain maintenance and cold chain equipments in the blood bank sector, coming to the diagnostic sector, where in a medical laboratory we are directly testing human samples and we are giving the reports to the clinicians and customers. We need to I need to recollect, or we need to remember once again that nowadays 70%, more than 70% of the therapeutic decisions are taken only on the basis of laboratory reports. So it is very important that when a patient's management is being done, how the accuracy and the precision of the laboratory report, that matters a lot. And if we go through the history of the laboratory medicine, even today, not only in India, but it's a global statistics that more than 70% of the laboratory errors, if it is really a laboratory error, that happens due to pre-analytical mistakes. That means pre-analytical variables. And we know that temperature variation or breakdown of the cold chain is one of the major pre-analytical challenge which all labs face throughout the world, not only India. And in India, as the diagnostic sector is largely fragmented, unorganized, if we consider more than 1 lakh laboratories are present, maybe only 1% or 2% are NABL accredited. And apart from accreditation, very few labs maintain that kind of quality. Then we can understand what is the magnitude of this problem. So starting from the collection, when a patient sample is being collected in a sample collection facility or collection center, the sample pickup or the logistics service may be delayed. Maybe the patient has given a blood sample as 8 a.m. fasting blood glucose, but logistics pickup is scheduled. The first pickup is 11 a.m. So if we do not maintain the cold chain, if we do not keep the sample inside the refrigerator, whenever the sample reaches lab, what will be the result? We are not at all sure. Not only about the collection at the collection point, but during transport, how the logistics boy are sending dispatching the samples to a lab, how it is being transported, we need to take care. And that's why the ISO 15189 2012 and even the current version 2022, they have recommended, actually it's an advisory that real-time tracking system entire from the point of collection to receipt to the laboratory, the temperature monitoring must be done. And we can maintain this kind of cold chain whenever we are using that kind of special transportation box with adequate ice pack and adequate sample transport policies or procedures. After getting in the lab, it is sample processing until the statisticians are processing the samples. We have to maintain the cold chain of the sample. And not only about during processing, after sample processing also, we have to preserve the samples, right? For some, as per quality management system policy of the laboratory, it's called sample retention for a particular duration, maybe for 24 hours for EDTA whole blood, for serum sample, maybe 48 hours or whatever. Sometimes we get also complaint or concern that the sample needs to be rechecked. How we will recheck and how we will give a precise report and we will prove that our previous report was right, unless we preserve the sample in a cold room or a particular refrigerator. So it is not only about the sample. I will also remind that the reagents which are used for patient testing purpose, that should also be kept in a continuous cold chain facility so that they do not get deteriorated. Because if you are running a reagent, running a sample with a reagent which is already deteriorated due to lack of cold chain or cold chain breakdown, your reports are bound to be an erroneous report. So both for reagents and samples in a medical laboratory, cold chain maintenance is very, very critical.
Thank you so much for your inputs, Dr. Banerjee. Moving on to Dr. Kapoor. Dr. Kapoor, could you please comment on the impact of plasma freezing on the factor 8 recovery?
There are certain proteins in our blood. We call them the coagulation factors. These are the proteins which specialize in stopping our bleeding in the body. They forms the clot by a series of mechanism and the cascades way. A portion of these proteins are known as heat labile or temperature sensitive. That means when they are exposed to certain temperature above 37 or 40 degrees, they lose their structural integrity and their function as well. So most important in a plasma, in view of transfusion medicine is concerned, we take factor 5, factor 8, and to some extent factor 9, 10, and 13 as well. But factor 8 is the one which is most sensitive to temperature. And it is also one of the clotting factors with the shortest half-life. It persists in your body for around 8 to 12 hours, and outside it depends on the temperature as well. So when we are freezing the plasma, our main aim is to achieve this process as quickly as possible so that we do not lose the structural integrity and the function of these proteins as well as of the other constituents of the plasma, so that it doesn't affect the quality of a product.
Dr. Kapoor, since you mentioned about like preserving plasma and the quality of it, could you also comment on the differences between a conventional deep freezer and a plasma shock freezer?
Okay. So both these equipments, the conventional plasma freezers and the contact freezers, they differ in the process of how they freeze the plasma and also on the speed of plasma freezing. So the conventional your freezers, they use air convectional process, and they use a slow freezing technique. That is, the temperature of the freezer, it lowers down slowly over a period of some hours till the plasma reaches its storage temperature. as a result of this slow freezing process, there's certain ice crystals which develop in the container or as well in the plasma. These ice crystals, they affect your storage container as well as the molecules that I talked before. So and while in contrast, when you talk about the contact shock freezers, they use the rapid freezing technique. That means that all this process of freezing, of collection to freezing of the plasma, it happens within minutes. Your storage temperature of around 30 to 50 degrees Celsius, minus 30 to 50 degrees Celsius, it reaches in within minutes. So, and also the way we keep the products in the conventional and the contact shock, in conventional, we stack the plasma box either vertically or horizontally. So the air current, it doesn't move equally and affect its freezing, and the part of the bag, the differential freezing happens. But in the contact freezer, your bags are in contact with the conducting plate. These plates are either cooled by liquid nitrogen or some other coolant. And so the process of freezing is equal. So you get a very streamlined process of freezing, which improves your overall quality and effectiveness of the product.
Okay. Dr. Kapoor, moving ahead quickly, could you also just comment on, like, as blood components have varying shelf lives, what are your views on heat liable coagulation factors and the importance of faster cooling in the preservation of plasma?
So Dr. Rima ma'am has already covered the shelf life, but I'll just give a brief synopsis. So when we donate 1 unit of blood, it's separated into different components as per the need of the hospital. But these components, we say if so-and-so component has a certain shelf life. For example, your PRBC, your red cells, when it's stored at 4 to 6 degrees Celsius, we can store it for 35 to 42 days. Your plasma, when stored at a temperature minus 18 or degrees Celsius or below, you can store it for 1 year. Similarly, for platelets, when they are stored at room temperature, that is 22 to 26 degrees Celsius with continuous agitation, you can store it for 5 days. So these have variable shelf lives and variable holding period, but the temperature is important. If we keep the product outside of this appropriate storage temperature condition, the shelf life changes. So depending on the shelf lives, as well as if similar goes with the plasma proteins as well. If I have to say in just one line, I will say ki shorter is the freezing time, the faster is the recovery. But it's not just on the freezing time only. There are various factors which governs the recovery of the factor. See, we judge the recovery of anything by studying it in the patient, how the patient is responding. So patient factors play an important role. Then the process of freezing takes, how you are processing the plasma product, your freezing process is important. Your speed is important. How you are handling the containers from collection to transportation, everything matters. So recovery time is governed by all these factors.
Thank you so much for that, Dr. Kapoor. Coming back to Dr. Banerjee. Dr. Banerjee, if you could just comment on the major challenges that the diagnostics industry is struggling with due to poor maintenance of cold chain and the possible solutions to overcome these challenges.
Yeah, thanks, Prabhat. Actually, as I told, in India, there are different types of laboratories. Some are corporate giants who are playing majorly in the metropolitan cities. They are concentrated there. The others are very fragmented, unorganized sectors who are playing in the Tier 2 or Tier 3 cities or even the rural settings. The corporate giants have also extended their presence in view of small network laboratories, satellite laboratories, etc., in other parts of the countries. But the issue is sample transport, because the distance, especially considering if we consider a referral laboratory in Kolkata, Mumbai or Delhi, maybe that particular giant is receiving samples from throughout pan-India, from different parts of the India. So obviously the logistics time is a challenge. And during this transport, if the transport time is delayed due to any cause, due to whatever the transport, any issues or something like that, then it is an additional burden on the challenge on the cold chain. So we have seen, I have experienced many cases is even during COVID time that we have received samples from a particular very remote settings or like that, because at that time PCR and those things were mainly available in the cities. So we are getting samples from the periphery, and they have given the ice pack, but due to some delay, due to lockdown or something like that, those ice pack, they have melted. And once we have received in the laboratory, the acceptable temperature is, it is not acceptable. The temperature is beyond 10, 12 or 13 degrees centigrade. So obviously there is a rejection as per quality management system procedure of the laboratory, and at the same time patient suffers, right? So we have to ensure that this humans sample, when it's a medical laboratory, we cannot collect samples repeatedly from a patient, especially when it's a pregnant lady, when it's a very fragile, senile patient, it's a newborn like that. So we have to take enough precautions that we are handling very precious samples. So these are the challenges, especially for the laboratories which we are handling. I have seen that many laboratories, they have good intentions. They want to implement the entire process flow of cold chain in the laboratory, but cost is a constraint. Maybe they do want to maintain a good quality, but the volume is not sufficient. So the laboratory is not very much profit making. So the cost of the equipment, cost of a cold chain, a cold room, commissioning a cold room in the laboratory obviously comes with a price. So that are also challenges, that sometimes there may be inadequate refrigeration system. As I told, some reagents in the laboratory need -20 or -80 degree preservation. Suppose for COVID samples, or any infectious samples in molecular biology, extracted DNA and RNA, being very fragile genetic elements, they need to be preserved in a -80 or -20 degrees Celsius refrigerator. But those are very costly. So maybe the laboratories are keeping them or preserving in a simple 2 to 8 degree medical refrigerator, but that is not adequate. So such compromise of quality may also happen, and not only due to, resource, it's in a resource limited setting. So coming to the solutions, number one, what I would recommend that awareness, that is most important, because we need to conduct this kind of symposiums, CMEs, where we will learn about these things. We can make people aware regarding the importance of the cold chain maintenance. And I would request, maybe in next time we will also involve, and maybe already they are attending, there are many clinicians, they should also be engaged in this kind of CMEs or symposiums, because we the laboratoricians, or we the people from the blood bank, pathologists, or maybe we are well aware, but what is about the patients, what about the customers? They should also ask the laboratories, they should also ask the particular collection center, okay, are you maintaining that kind of cold chain when you are transporting the sample to? So that is the importance, when even people at grassroots level also we should be aware. So this awareness. Number two is robust implementation of the ISO 15189. See, maybe accreditation and those things in India are very much limited. Only a few laboratories are going through this kind of accreditation. So we have to implement maybe this another debate. There's another matter of another CME, that whether accreditation should be made mandatory in India. But accreditation helps to improve the quality, to improve the awareness of the people. And number three, the Make in India initiative. As the medical systems, they have it's a PPP model. It's a government of India. They have set up a combined activity. Such kind of government should come forward, so that there is a Make in India initiative without compromising with the quality. We can have a warehouse, we can have manufacturer plants where we can prepare this kind of medical grade refrigerators in India itself. We do not want to import the parts or like that from abroad, so that everybody, if the cost comes down without maintaining, without compromising the quality, all the laboratories who are even very resource limited setting, very small laboratories, they will also be able to avail the facility of cold chain, right? So our aim is to give the best quality of service, not to a particular population, but to the maximum in the entire strata of the society, of all level of people, so that they are also able to take the advantage of such cold chain maintenance facility. And so here the government may play a huge role, and I am sure that already this kind of initiatives, as we can see from the medical system, this is already aware, and that the solutions, I think. So that's all.
Thank you so much, Dr. Banerjee. Yes, Dr. Sawant, you wanted to add something to this.
Yeah, so thank you, Prabhat. Actually, Dr. Banerjee has extensively covered the importance of maintaining and monitoring the temperature of samples. So similarly, I thought two very important scenarios are worthwhile highlighting here. Especially in the last few years, we have permission from the government for bulk transfer of blood and blood components. Previously this used to be done very, very rarely, but today this is very commonly done within the city, between cities, and even interstate also. So, you may have a Bombay blood group unit collected somewhere down south and being utilized, say, at Delhi or Lucknow or one of the northern Indian cities. So, a lot of relevance for maintaining temperature during transport and also monitoring the temperature. Both are very, very important. Another scenario which I quickly wanted to highlight is you have a lot of stem cell donor registries. We have more and more Indian origin donors getting registered. And therefore, what is happening is that you may have a stem cell donation happening at one center, and those stem cells will then be shipped to the center where the patient is receiving the hematopoietic stem cell transplant. Again, a very, very important role of maintaining temperature as well as monitoring the temperature. So this is something which I thought was worth mentioning here. Thank you so much.
Thank you so much, Dr. Sawant. Now, since we are really running out of time, I would like move forward and get to the concluding bit of it, wherein I have a question for Dr. Bhatnagar and Dr. Menon, but if you could just keep this very crisp. Dr. Bhatnagar, what is the current scenario in a country when it comes to cold chain management of blood and its components?
Prabhat, current scenario, as I would say, is as we've discussed this in detail, that inside the blood center, there may be maintenance of cold chain. But when the blood, as Sawant also said, when we are transporting the blood, say the blood transfer, then at that time, and also when we are issuing to the patient, the clinical side, the user side. So at that time, the blood, the cold chain maintenance, that is a weak link, and that we need to strengthen.
Okay, thank you so much, ma'am. Ma'am, you basically are saying that preserving it and separating the different components of blood and preserving it is not an issue, but the transportation is the weak link in the chain.
Weak link, yes, yes. And another weak link is, as everybody is agreeing, that this is a critical point where the training and this more discussion on this aspect, the equipment maintenance, the cold chain equipment maintenance is it should be center stage now. And as I said, that we are from the medical or paramedical, so the attendants who are handling the blood products, they also need to be trained for this. So the training part is also a key critical aspect.
Thank you so much, ma'am. Dr. Hiregowda, what do you think, like how solar power refrigerators for the management of blood can help them reach remote areas in India? Dr. Hiregowda, are you there with us? Okay. No issues. Dr. Kapoor, would you want to take up this? Dr. Kapoor, you're on mute.
Am I audible now?
Yes, Dr. Kapoor.
So as I was saying, India is blessed with sunlight. So yes, anything which is based on non-conventional method of energy, India will be very, very benefited by it. We see that most of our health facilities and infrastructure is concentrated in and around the major cities. We struggle to reach, but a major chunk of our population still live in the rural areas, and in most of the times they are not able to access to these facilities. So by using the solar-based equipments, or by using the portable mobile equipments, yes, we can increase our reach and we can help our lots of people who are not able to access it right now. But in addition, we also have to look after the cost also, because all these innovations and the technological advancements, they look very good on paper. Yes, they provide you additional benefits, but not each and every blood banks or lab, they have the same set of resources. So hospital wise or the patient wise, you have to look at what you are catering to your population, market, what it is, and We have equipments which are made in India, but they are, as when we compare it with the branded ones, which we have put from US, Europe, or America, they cost you 1/10 of what they cost you there. But still, it is not very economical to have everything standardized. So we need from the government side as well as from the regulatory authorities to have a stringent measure so that which allows Indian markets to prosper and up to the standards. I'm not just saying कि उनको वहाँ से एकदम हटा दीजिए, but yes, we need to improve our local market so that we will have more trust and confidence of using our Make in India products.
Thank you so much for that, Dr. Kapoor. Coming back to Dr. Menon, Dr. Menon, if you could give us some insights on what role could the government play, but please, since we are running out of time, if you could just be to the point, that would be great.
I think what the government needs to do is standardize and make all of these systems and processes that we just discussed more uniform. We have a wide choice, just like our lifestyles and everything else. We are a huge country. So if we could bring in systems which are uniform, and if the training, for example, could be uniform, the SOPs developed could be uniform, that would help to a very large extent in unifying things and having trust between institutions which follow probably diametrically opposite processes and procedures. So I think that sort of a centralization of all activities related to blood and blood products, it's very good on paper, but yes, it's difficult to implement, I understand, but it is doable. When we have done so much in other areas, it should not. If food industry and vaccine could be taken on a uniform way, I'm sure we could do this with blood also. So I think that's where the government could come in and help us.
Okay. So sorry, Dr. Menon. Yes, Dr. Kapoor, please go ahead.
One quick point, if there could be a bifurcation of the services with the government, because current Indian scenario, the drug authority, the food administration, they are looking after your equipments, your drugs, your blood banking, everything is clubbed together right now. So a lot of time we face red tapeism and hurdles in this. If we could, if the government could bifurcate it or just give some regulatory easement to one or the other faction, so it will really help in speeding up, and digitalization is the way. So if we could bring each and everything on digital platform, so like licensing and everything, so it will be very benefit.
Thank you so much. Now, since we are really running out of time, one question I'm going to take from the audience is the question, if anyone would like to take this up: does blood get wasted because of temperature excursion during transportation?
Yes.
Yes. Yes.
Okay, yes. So I think that gives us time for one more. There are many different components in the blood, like enzymes, proteins, lipids, etc., all having different temperature requirements for stability. How we can deal with this problem? This is from the audiences.
Plasma as such is
Dr. Bhatnagar, yes, please go ahead.
Yeah, so there are guidelines which Madam also said, that there are defined guidelines on, like, red cells need to be preserved or stored at particular temperature, platelets at different, and plasma different. So when we are maintaining the temperatures like this, definitely all these are preserved. The shelf life is also defined.
Okay.
So for laboratory perspective, I would like to add one thing. There is definite guideline from ISO 15189, NABL 112, etc., which samples to be transported at what temperature. For some samples, most of the samples is 2 to 8 degrees, some are room temperature, and some samples are in frozen with dry ice. So those are analyzed. Specific stability depends on at what temperature you are sending. So there are specific guidelines for that, CLI criteria.
I think that would be it. Thank you so much. We cannot take any more questions because we're already out of time. Thank you so much for tuning in. Thank you so much, Dr. Sawant, for joining us. Thank you so much, Dr. Menon.
Thank you so much.
Thank you so much, Dr. Banerjee. I don't know whether Dr. Hiregowda is still with us, but thank you so much for tuning in.